Yeah, we can wait for a little bit, I think.
Yeah, or we can just start.
Or
I think
we
can
can
always
start
do.
and then, yeah, maybe that's better.
Yeah, I think that's better. Let's don't wait on him. So, Jelle
All
want to
right.
start or?
Yeah, I can share some updates.
Oh
Although,
yes, we want to hear
you
that.
know, finish up the logging, as usual. I did make some progress again. Though I have some bits that I'm not really stuck on, but I'm not sure how to handle it, so I'll throw it in the group. And yeah, I guess I'll just do that now. So for the logging, we have the RTC value. So and for the M5 core, we don't have an RTC module. So I think last week we said we will just use the RTC clock for all internal values or internal processes, etc., like logging. I did update the sensor framework a little bit with my latest push on Monday, I think it was. To summarize, what I changed is I added a new worker type, which is a process worker. And that worker takes in workers as well. So it's like a step between the worker doing its work and the handler handling all the workers' work.
Mhm.
There's now a worker in between that can also look at the worker, change things. So also the log aggregator is a process worker. So it will take work from all the other workers, like the GPS and the Geiger counter, and then create its own work data based on that data, and then the handlers can handle it in the same cycle, which is quite useful, I guess.
Yes, I think.
And I also changed the RTC worker to be like that, and it now reads the GPS date and time, and will also set the real-time clock based on the GPS if it's currently not set. We have to think of some algorithm for that, as well as how to update the RTC. And based on that, I also updated the M5 stack implementation of the RTC because, well, it doesn't have a module, but we can still like say, well, we have the GPS value and just put it in there, and then we just provide the data from the GPS as a real-time clock value. So we can just use the RTC data in both the M5 Core 2 and the Core 1.
Mm-hmm.
Yeah, we have to maybe make some custom RTC implementation for the Core 1, where we just up the seconds
I
every.
wouldn't focus on the core one because I think that's only for the last 15 I have left or 13 I have left, and that's all going to be. I
All right.
can run the other software on it for the moment. It's just for testing the hardware. I mean, so
Right. Okay.
focus on the core 2 and core 1 is it's nice if it can be, but it's not a priority at all.
Yeah, exactly. Okay, so we can just use it as I made the first simple version, which is it just takes the daytime from the GPS, and if it's not available, it's not available anymore. So,
So, so what you're saying, as far in terms of real-time clock, is you go with the GPS value, and if the GPS is down for whatever reason, including while the device is off, you rely on the RTC that's internal
that's for the core too.
until you get your GPS back, right?
Yeah.
Now,
Okay.
GPS time can come back very quickly because all it needs is one satellite in view.
Right.
True. Yeah.
Yeah. Well, for the core 2, we focus on the real-time clock value, but I don't want to update the real-time clock every second based on the GPS data if it's valid. So Basically, the plan is to update it like once every hour or something, like after the first update. But currently it only sets the real-time clock once. If it's not set yet, it will set the clock.
How much does it drift according to you? If it doesn't drift so much, we can 1 hour would be fine. But if it drifts quite a lot, then we should think about maybe
Right.
after 15 minutes or something like that. 15
Yeah,
minutes.
that's
is
why I
fine
said
too.
we have to think of some algorithm that we can implement to update the RTC.
Maybe an intermediate solution is just do a compare to see how much they are drifting every hour
Yeah,
or something like that.
Yeah, that is one option we can.
Is it saved as Unix time or?
Yes.
Okay.
The
Yeah.
RTC is actually, it's a dedicated chip. It has its own battery backup and 32 kilohertz crystal oscillator, and it maintains registers as hours, minutes, seconds, date, leap year, does all that stuff. It was basically a digital watch for micros.
Right.
And there's 1 bit in the seconds register that if the bit is set, that means there's been a power failure and you can't really trust. In other words, the battery backup went away.
Right.
And you can't trust the result anymore. So I would say just set it at boot time and forget it. I don't think it's going to drift that much. I had mine off for a little while, came back, and it was like, like 1 second after 2 weeks or something like that.
Oh, I mean, we can ignore it.
Right.
Right. Yeah.
If all you're using it is for logging and file naming, then I don't see a problem.
Yeah, that is true. I guess we can just set it, like we can just check the day or something, and if the day is different, we can update it from the GPS, and then it should be fine.
Oh, sure.
Something like that.
It's also, it doesn't check the time zone, so it should be fine because it takes UTC. So we should be okay.
Right. Well, we also saved it as a UTC because we only have UTC time from the GPS.
True.
So, yeah, so I've been working on that. As for the logging, I was just working on the logging a bit. And I was also trying to handle the don't have a GPS log yet and might not have UTC or RTC values, which is maybe we can just like skip that. Like once the real-time clock is set, we basically always have the values. So maybe it's like a small edge case at the moment, like the first time startup, and then we don't have a proper journal name or something. But I think most people would have like a GPS log, at least a time log, quite fast.
If it's a file naming thing and you don't have the time, just give it a temporary. There's only going to be like a small number of journal files, so just start with a temporary name, and as soon as you acquire the name, rename the file, and the file system will handle that.
Yeah, that's my current implementation.
Did you try that to rename them when they're made?
Yeah,
it's important
there's a rename function.
Yeah, that works.
The library is supported.
Yeah, but the library support, but it really works.
Does it really work?
I don't really know. It's not really easy for me to take out my SD card and plug it into my laptop because the input on my laptop is like on the back. You have to like with a pin, you have to get it out and then plug it in.
Oh, really? Oh, what you can use get the USB thing for it.
I'm just assuming it works right now. Like from what I've seen in the library, I don't know. It's just renaming the path. So, but then I'll definitely try it at least.
Okay, at least once. Then we know at least it's doing the things what it should do.
They work once, ship it.
Exactly. That's good enough.
Oh, I like that attitude.
It works for Microsoft.
It's good. Yep.
Yeah. Yeah, but they have remote access again.
Well, we have like the M5 burner, so we can
That's
just
true. Yeah.
tell people, well, just install this and press this button.
That's true.
Okay, and then I was thinking about the file locations on the SD card for the logs.
Mhm.
I think the Nano divided them by years. Is
Yes.
that correct?
No,
Right.
it's not true. The
No,
Nano overrides them. It really, if
Oh,
it's the
okay.
same date, it will override it. Or
No, it
append it. Sorry,
depends.
append
It
it.
depends.
Append it.
Ah, okay. So okay.
But you don't know if it's
Um,
appended or not, because you can only, if you have to look into the file to see which year it is. And that's a
Right.
kind of hassle to do. But that's the way it was set up, and we were not expecting it for 10 years to run at least. So it's running
I
way
think
long.
for the Zen we have a new file naming format. I
Yeah,
think.
Robin makes it in folders. Anyway, Robin already made it in
Right,
the
yeah.
folders, but if we have a real date, that's much nicer in a year. And
Yeah, I wanted to use the file name as I mentioned in summer somewhere to also have like the log viewer that where you
yes,
can read the logs and parse the file name and know, oh, this is like a good log or like it has been uploaded, things like that. We wanted to work with that as well. Yeah, I'm thinking maybe we can make like different directories for Drive, survey, and journals, or put them all like in the root. Is there a
no,
preference?
don't
Or?
put them in the root. And that, at least that's my preference, because that way people get confused from what's that, and they don't see it. If it's in a separate folder, it's very clear. It's a different thing.
Yeah, we can call it like Drive logs, and then have like a Drive log named
Yeah, but still,
Drive with the
people
date.
who
Yeah.
don't understand what we're doing, they see this file and
Mm.
say, "Hey, what's this?" And I mean, I've seen that. Even if it is just an extra file, they go like they don't understand what's going on. You have to make
Yeah,
it for
maybe they
dummies.
delete it, or no, that's a good idea. So just
Just a
clear file
folder,
name.
different folder. It's more safe.
Okay.
On that topic,
Um,
should there be a different directory for config files, or should they be at the top level?
And the Nano, it was
Uh,
at the top level, so I think it should be on the top level to be a little bit more consistent that people have been using Nanos. I mean, that's my feeling.
Sounds
yeah, I
good to
like
me.
the config at top level. I
Hmm.
think.
What do you think, Michael? Top level or?
Yeah, that's where most people would look for configuration for a device, right?
That's true. In the root.
It kind of depends. Like if it's like a big application or something, you would expect like a
That's
config
true.
directory maybe, but this is just like a logging device SD card, so the config can just go into the root, I guess.
Yeah, I think
I mean,
so.
we can always change it and then just let people know that there's a new location. Although,
Keep it
yeah, I
simple.
don't know.
Keep it simple.
Let's just keep it in the root.
Yeah.
No problem, no issues. The
That's-
root will be clear anyway because we have different directories for the logging, and then there's nothing else there. So.
Yeah. So you want one
Um,
for the locking and one for the journal, or the journal is together with the locking? What do you think?
I was thinking one for the journals. So we got a directory with journal logs,
Mhm.
with drive logs, and with survey logs. So people know what they have been logging because they started start logging on a drive, for example, or maybe a survey. And then on the SD card, if they explore it, well, they can just go to like, oh, I was doing a survey, open survey directory, and see different survey logging files. And based
Yeah, I
on the
like
date,
that.
you can then decide what you do.
Yeah, I like that idea. This is good. Yeah.
Yeah, and also
Yeah.
for the log viewer, which is a feature for later, we can just open, like, read the directory and like list all the logs in that directory, for example. Then we don't have to parse every file name, blah, blah.
It makes
Just
it
an
easier.
idea.
Louis and Michael also think like that. That's a good idea. This way.
You're talking about viewing the log file on the device itself?
Yeah, we
Okay.
had this idea for a feature like that.
Yeah. So a scrollable log. Yeah, I like that.
Okay.
But later.
Later. Yeah.
Yeah, it's
High
to see the
priority.
log and if it's uploaded or not. And you can upload it directly from the device to
Oh,
the
that's
API.
good.
All right. Yeah, so that's my progress. Anyone else on progress?
Yeah,
Perhaps?
I've been doing backing, and I'm being set up for organizing the production, and I have to organize things and see where the suppliers we can get and prices compare and this kind of things. So also for the safe pulls, I have to find other assembly line. So, but that will come. That I've been working on.
All right. We're able to see if you can upload the 7-digit or the 7-segment
The
font
fonts,
file.
yes, I can upload it. You want me to put it on in the files on the GitHub? That's maybe easiest.
Yeah.
Yeah.
If we can do that.
Yeah.
And we can also start on like implementing the screens.
Yeah.
With
yeah, I like
fonts.
it. Yeah, I really look forward to the screens to show up.
Right. Well, the drive screen is already like a bit made based on what Robin already made.
Yeah. Yeah, Robin and me made that. I made the basic
Robin.
layout, and then Robin implemented most of it.
Yeah.
I think he did a good job on that. I like that, the layout.
All right.
And Michael has something to report, or you've been busy?
I was busy with projects here, winter, getting the house ready for winter, and then this vaccine thing. I'm now drinking water, so I did get I think as a first pass for a GPS emulator, I got the TT 4.1, and so I was just going to modify the library. So not only can you read, take a UBX block of data, but and read the contents, but also write the contents and be able to send it out. And that way, we could store and modify and release.
That's very nice. Yeah.
Yeah. And then I liked your idea. We could take it and we don't, if it works on a core, we can do it there. So that people wouldn't have to buy different hardware for this.
Yeah, that would be nice.
Yeah.
So you can emulate it on the core itself and then show it up. Yeah.
Right. I mean, there's always the advantage of going all the way out to the serial interface.
That's a more realistic approach.
Yeah.
You can use a string stream on the core and pass that to the GPS connector as the input stream, and the hardware serial is also a stream, so you can write to the stream from another component, and the GPS connector will just pick it up. It's a nice way to test.
Yeah, there are also 2 cores on the core, 2 CPU cores, so you can make different threads if you want to.
How does the compiler choose what gets executed on each core?
You have to set it up for it.
I see.
So one task runs on one processor and another task runs on another processor.
Right.
So you make basically 2 tasks, and they're completely independent.
Right.
I think they share the memory only, so you can pick.
Does the GPS when you set it up, do you do polling or Louis, or does it you just set it up to stream every second?
I set up the GPS module to blast out a solution once a second, so it's going to do that automatically.
Right, and so a worker picks that up.
Yeah, That's one of the options in the library. And then so it basically picks up the serial stream, and then when you query the API, it gives you the most recent.
Right.
Oh, talking about the API, I think an important point for Jelle, I think, if it's the data is being sent on the Wi-Fi, can we get a measurement for every, get a measurement ID from the measurements that's being sent, if it's in fixed mode? That will be nice, and store that, because then you have an indication that the measurement is in the API.
Yeah, might be useful for debugging at least.
No, not only
to show it on the screen.
No, not to show. We don't have to show it on the screen, but as a reference. So this is absolutely this is accepted by the API, and if the API is down, you can make a warning. Or
is
something.
That the API response? Does it return?
It does return a measurement, an ID. It gives an ID, and the ID. If you do a curl, then it will directly spits back if it's accepted. I can give you the command line for it if you want to.
No, it's okay. I think currently we do nothing with the response from the API. At least, well, currently we don't have fixed mode, but but based on the bGeigieZen cast, we use the same code basically. We just debug, print the response. But yeah, if the post is complete, like a success, didn't get an error message or error code, then we assumed it was correct, but we can do something with the ID as well.
Yeah, because
we then have to parse the response, so I don't know how good that is performance-wise. If we can assume that what is the response? 200?
I think 200 is okay
yeah, well, 201 is usually created, but I think the API sends a 200 response. We can assume it's good enough. Like, I would expect it to be a success. I don't know if it's good to parse the response data and see if there's a message ID. Maybe as like
it's quite short. I mean, it's an ID. It spits back and some extra data was being stored, so you know what's being stored.
Yeah. Okay. Well, we can take a look once
later. It's not a priority, but I've just
once we work on the fixed mode, we can take a look.
Okay.
I'll just add it here to the to-do.
So one of the things I put in my small device projects is you have your inner working loop, right? Was it workers or handlers or both, right? And one of the things I always want to measure is how taxed is the system, and in worst case, and one of the gross, really simple ways to do that is how in that iteration loop, how much time, how much time am I spending in that loop, worst case? Because sometimes you might have just super event where all these workers and handlers have to deal with their task all at one shot. I don't know. This is a much more powerful processor than some of the units that I use. So I just put a timer loop in there, and I get the highest value, and I kind of just throw that out on the screen. As I turn on a switch and then throw that out on the screen. It's like, well, how busy is the processor at this point? And that's one way, is just like what's my time? What's my time through the loop? It's just when we talk about bulletproofing, you also want to know, if you're nearing a point where you might like lose a GPS message, or you might lose an event from the Geiger counter.
Yeah,
I don't know
Geiger
what you
counter
guys think of
effects
that.
are kind of unforgivable to not to pick up.
Yeah. Yeah, because yeah, your interrupts affect that loop time as well.
Mhm.
Yeah, it's a good point because I think the most busy cycle would be when there's a new log to be logged. So you get like the writing to the SD card, to the journal, to the log file itself if you're logging. Then
Right.
also, although, well, I think when you're in fixed mode, you got the API, of course. Then it doesn't log to a drive log, but it will still log to the journal.
Right.
But in fixed mode, the API connection, that would be the slowest, basically.
Right.
So perhaps we will have to do like the API upload in a separate thread.
Separate,
Perhaps should take a look at that.
Yeah.
I do remember from the bGeigieZen cast, it can take a while depending on your Wi-Fi connection strength.
And also
So,
the latency. So.
Yep. I think that's a good one to keep in mind.
Yeah, it's a very simple thing to implement,
Yep.
and you can turn it on and turn it off at will. Just you know, especially like you said, when you're overburdened, you're writing to the SD card, or you're sending your data, you're uploading your data. You know, and then that's another area where you might consider offloading to the second processor for some of those things. If that's possible.
Being honest, there's 3 processors even. There's an UPL processor also on it, but that's a very basic low-level processor. It cannot handle anything. But in case of emergency, it can store some RAM.
Right.
Yeah, isn't the ULP only for like sleep modes that you can still run like a small program to check to wake up?
Yeah.
Right.
It's basically for that, but it's still a processor you can basically use.
Not strong enough to send something to an API.
No, I think so. The SMT 32s are better. They store the whole memory if they shut down. That's kind of amazing. In the RAD node and the air nodes, they have them. Okay. Do we have other things that are on the list? Because I think we have about 10 minutes left, or 9 minutes.
Well, I think Josh had some
yes,
I
said he had something done, and I wanted to see finally something like that.
Yeah, perhaps next week.
Yeah, perhaps, or maybe
it's still too early for him.
Well, it's 6 a.m. for him. Yeah.
Yeah, that's
6:30.
But this is a good time for all of us, because it's a little bit late for me, but this is just okay.
Yeah,
everything's quiet around here.
Yeah, it's okay for me.
Okay, good.
So yeah, no, I don't have much to anything. I just started looking at the NO code, the interrupt handler for the pulses, and also started looking at the code, and it's just basically me just trying to get a good picture of what's happening, but nothing significant at the moment. It'd be nice to, like as I'm making notes, I can start documenting what actually happens. Just just to be out there, and then then we can compare that to the implementation in the Zen, and just make sure we're we're continuing that same basically the same level of integrity, if not better, and just not doing any serious work on a pulse emulator, but thinking about it. So I don't know, that probably doesn't count.
Me too.
Progress.
I've been talking with Toy Builder. That's Josip. about the implementation of building the hardware for it and with a FET, and he agrees that is the way to go. And he looked at the schematics and he suggested some changes on it, but overall it looks promising. I couldn't allocate time yet for it, but it will come.
Okay.
Mhm.
So you want to use basically a high voltage FET to just
Yeah.
just produce a
And
pulse.
then with high voltage FET with a small capacitor after it, so you get the real pulse like this.
Right.
And then make it randomly. I mean, randomly in the sense that normally the ionization happens mostly in the middle, but sometimes at the edge. So the voltage is a little bit lower, but it's still a pulse. So you have to think about that too. So,
In other words, so in the recovery, right, that RC climb, you might get a second pulse just as it's still climbing up. Okay.
Yeah, I was just thinking the hardware counter at the moment currently stores 1 second of Geiger counters. Because we changed the bin to 1 second instead of 5 seconds. So if we have a 1 second delay somewhere, we lose 1 second.
I think Ray had a trick around that. You should see the latest fix on the Nano, what Ray made. You should. I think it's.
Well, I already have an idea. We can use like a small circular buffer for.
Oh, that's also an idea.
For the hardware
Storing
count, so we
everything
can say like
then
store
compare it.
like up to 10, maybe 15 seconds.
Okay, yeah, that's great.
And then we can just
Yeah.
check if there's anything in the buffer, and we can take it out instead of having like a available boolean and a last count integer.
No, I like that. That's a good approach. I prefer that.
Yeah. All right. I'll
the
update that.
Yeah, the counter is just basically counting pulses into the hardware register. It's a hardware counter. Right. So once a second, it just gets cleared. Right?
Yeah, that's the if I look at the counter, well, it counts to a value, and every second it stores that value into the last count.
Yes.
And then it makes it available for the worker to read, and then the worker reads it, and then, well, you have basically 1 second to read it.
Yeah. Okay. I see the problem there.
Yeah. So by making it a buffer, instead of storing it into the last count, you add it to the buffer, and then the worker will just see if there is anything available in the buffer and take it out.
Take it out. Yeah, that's the safer way. I prefer that. Yep.
Yeah, that's. Thanks, Michael, for mentioning that, because
yeah, good point.
it is a downside of going to a 1 second bins for the Geiger counter. But with this, it's like at least basically fixed. I think if we have, if we miss hardware interrupts or something, like I'm not sure. I think all interrupts will go through. That's how it works, right? Well,
if there's no non-blocking interrupts, right?
No.
Yeah. Rob, you were working on a hardware counter that can do more than 60 hertz?
Oh, no, not a counter, a pulse maker.
A pulse maker, yeah, I mean.
Yeah.
Yes,
Sorry.
I mean, that's what we talked about with the FET. That goes together.
Okay.
Yeah.
That would be great if we can test that, as well as like maybe add like a delay of like 5 seconds somewhere and see if we missed any counts.
Yeah, and then we have an exact count going in, an exact count we can see what's going in. And
Yep.
I prefer that than using a tube, although in tube is realistic, but we don't know. We don't know the radiation.
Yes, yes.
Well, yeah, I don't have a calibrated source. Plus, I'm not sure I want a high count calibrated source hanging around the house.
You should go
Good
to
point.
Joe's house. It's it's amazing what he has. I mean, it's dangerous there. He has a special box.
Okay.
It's a special box, but he already has children, so he should be fine. So, okay, I think that's it. That ends it up for today. I think good. Good. Thanks for meeting, and I appreciate all your time and all the efforts.
Oh, enjoy it.
Oh,
Okay.
that's it. Yeah, same for me.
Thank you, everyone.
Yeah.
Yes.
All right, thanks. All right,
And,
Bye.
Have a nice Sunday.
yes.
yes, you too.
Okay. Bye bye.
Bye.